Now let us define the tolerance zones of the pattern of holes as shown over here in terms of the equations as we had done earlier for the rectangular pattern. So how do we do that for a circular pattern as shown over here? So let us do that. So the first step is defining the origin or the coordinate system based on the datums which have been defined. So the origin will lie over here at the intersection of datum B and datum C and datum A. So this is the intersection point of datum A, B and C, and hence this will be the origin. Let us consider the horizontal direction as X and vertical direction as Y. Important assumptions made for the definition of the tolerance zone is that we are verifying position only in 2D. We are verifying position considering that the perpendicularity variation of these holes with respect to the datums is negligible as compared to its position. Considering this major assumption, we are going ahead with the analysis and developing the equations. So the equation of a circle which is located at a coordinate h, k on the xy axis is given by x minus h the whole square plus y minus k the whole square is equal to r squared, where h and k are the coordinates with respect to x and y axis respectively. So we need to develop the equations for three circles, 1, 2 and 3, which define the three tolerance zones based on this feature control frame of the geometrical control, positional control, and then use those circles as a reference for evaluating the actual measurements for the position and size of the holes. Now let us find the coordinates for the center of the three tolerance zones which are corresponding to the three holes on the path. So let us do that for this one first, the topmost one. So from the drawing we can make out that in the x-axis, the x distance of this hole is nothing but 70. So 70 is the x distance on the drawing. The nominal dimension of this hole in x is 70. So x coordinate is 70 and y coordinate is 40 plus half of this pitch circle diameter, which is 45 divided by 2, that is 22.5. So 40 plus 22.5 is 62.5. So the y coordinate is 62.5 and x coordinate is 70. So 70, 62.5 are the coordinates for the center of this tolerance zone, which is defined concentric to the hole over here. So the equation, we can write the equation as x minus 70 the whole square plus y minus 62.5 the whole square, and the condition over here is it should be lesser than or equal to 0.1 squared. 0.1 is coming from the value over here, 0.2 divided by 2. So 0.1 squared, that is r squared. Now to find the coordinates of the other two centers of the circles, we need to draw a right angle triangle which is connecting the center of the pitch circle and the center of the tolerance zone over here as shown. So this right angle triangle, from this right angle triangle we can find the horizontal distance of this center with respect to this and the vertical distance of this center with respect to the center of the pitch circle. So doing the calculations for the right angle triangle, we know from geometry that this angle is nothing but 60 degrees. So these holes are divided equally with respect to the angles, that is 360 divided by 3, which means that each sector will have 120 degrees and half the sector is 60 degrees. So this is 60 degrees and this length is 22.5, which is nothing but the radius of the pitch circle. 45 divided by 2, 22.5. So from that we can find out this vertical line and this horizontal line distance. So vertical line distance is 22.5 cos 60 in degrees. 22.5 into 0.5 we get 11.25, and the horizontal line is 22.5 into sin 60, which is 22.5 into 0.866 equal to 19.485. So these two lengths are 11.25, 19.485 from geometry. Now with that we can find out the coordinates of this point and this point. So the coordinate of this point is nothing but in x it is 70 minus this distance, which is 19.485. So from this point to the y axis it is 70, and if we minus 19.485 we will get the distance of this point from y axis, which is 70 minus 19.485. So this is the distance on x axis, and on the y axis the distance is 40 minus 11.25. So this, from this edge to this center of the pitch circle, it is 40, and if we minus 11.25 we will get the line we will get the distance of this line from the x-axis, which is the y distance. Y is equal to 40 minus 11.25, which is 28.75. So the coordinates of this center of this tolerance zone are 50.515, 28.75. Using these values, if we write the equation, which is the condition for acceptance of a point which has to lie within the tolerance zone, then that condition should be satisfied as this one. It should be lesser than or equal to 0.1 squared. So in place of the h and k, we have substituted the values of 50.515 and 28.75 respectively. Now to find the coordinates of the last center of the tolerance zone, which is this one, it is fairly easy because it is 70 plus 19.485, because this right angle triangle is symmetrical based on the center line of the pitch circle. So 70 plus 19.485 and y is 40 minus 11.25. Y coordinates stays the same for both. So 89.485, which is 70 plus 19.485, and y coordinate remains the same, which is 28.75. So writing the equation in form of the h and k, which has been found. So these three are the governing equations using which we can find out whether a part which has been manufactured with respect to this drawing is acceptable within the limits or not.